Today's lesson is on ionic compounds, carrying on from last time when we looked at ionic bonding. Same format as always. You need something to write with, something to write on, and you're going to need your attention span. Using it as always, pause the video, answer all the questions and check your answers. It's really important that you're doing those retrieval questions and really important you're having a go at that independent practice. If you are struggling with the independent practice, the questions are going to get a bit harder as we go through. Rewind, rewatch the explanations. It can be really helpful to have that explanation going and having a go at the question, using it to help. Okay. Here's your periodic table for reference, and let's get into the retrieval. Okay, so I want you to start by thinking about common table salt, what we put on our fish and chips. So you have a little shaker and it'll be full of salt. I have salt and vinegar. Now if you pour that out, we're used to it being that kind of powdery substance. But something you might notice, if you really zoomed in and look at an individual particle, you'd see it has a really similar kind of cube shape. They have these kind of cuboid 3D structures. Now salt is an example of an ionic compound. It is sodium chloride, what we talked about last time, one atom of sodium and one atom of chlorine held together by that electrostatic charge. If we zoomed in even further on that cube and we looked at the individual ions, let's start with our positive ion, that metal one. That charge doesn't just go in one direction to the chlorine next to it as we were drawing. That charge works in all directions around the ion. So negative ions, the chlorines, will attach in all directions because that's where that force is going. And then around those chlorines, that negative charge is also in all directions. So around those, you'd find the positive ions. So we can see straight away, this is building up into a big cube-like structure. So that as it works in all directions, it's going to build a 3D shape around it into a cube. So those ions are working in all directions. We call this shape, where the ions form that regular structure, a giant ionic lattice. Giant ionic lattice. And the forces between each of those are really strong. So between that positive and negative ion, that electrostatic force we talked about last time is really strong. We talked about it similar to being that north and south pole on the magnets. So remember, if you try and pull those magnets apart, it takes energy to pull apart two magnets that are stuck together. And it's the same for this. If we want to pull apart those ions so they're separated, you've got to overcome that force. You have to put energy in. Okay, so lots of energy is needed if you want to break those apart. Okay, and if we're breaking apart ions, atoms, separately, then we're going to change their state. If we pull them all apart, we can make them liquid, and if they're moving around freely, we'd know there'd be a gas. So because we need lots of energy to pull them apart and change that state from solid to a liquid and finally a gas where they're apart, each time more energy needed, we would therefore say that they have high melting and boiling points. So we need really high temperatures. So that means lots of energy to pull them apart. Okay, and that's not just for salt, that's all ionic compounds. They have high melting points and high boiling points because of that energy. Let's look at another property of what happens. So we're kind of aware of in the sea, there's lots of salt in the sea, we call it salt water. And you've probably done that experiment at primary school where you take salt and you mix it into water and you make like really salty water. You might have done that in separation techniques, splitting them apart. So we're aware you can put salt and it breaks up in water. So let's have a look at what really goes on when we're doing that. So if we start with our giant ionic lattice, those positive and negative ions in there, we could label them all up. It's positive and negative. We put those into our water. So these molecules here are our water molecules. When those ions go in there, we know when you put a big lumps of salt and cubes in there, they don't stay as those big lumps, they break apart. And so in there, what we end up with is those ions separate from each other. So we have some positive ions in there, some negative ones, and they split apart into their separate atoms. Now because they're charged, and because they're free to move and carry that charge, they're actually able to conduct electricity when they're in solution like this. So we call it a solution because we've got a mix of them. Okay, so that flow of charge, that carrying of the charge, is conducting electricity. So they will conduct electricity in solution, as well as when they're molten. Molten just means when they're melted and as a liquid. So when they're liquid, they're also able to move over each other and carry that charge. So they can conduct electricity in solution and when molten. Now remember, these are properties of all ionic compounds. So any named example of an ionic compound is going to have these properties. It will conduct electricity in solution and it will have that high melting and boiling point that we've talked about. Okay guys, have a go at that, embedding that knowledge. Go back, take some notes if you need it, watch it through the first time, but go back, get some notes down, self-test yourself on those notes. Okay, make sure we've written down the key properties that we're expecting of ionic compounds. Go through it, self-test, or get someone to quiz you. Right, here's your independent practice. Right, have a go at all of these. Go back, watch, re-watch the explanation as much as you need to. And last one. Here's your answers. And last one there, well done if you managed to get all of those. If you didn't quite get some, or you got some wrong, go back, re-watch the video, look where you went wrong, try and correct yourself. And that's everything for today. Well done guys, let's keep up the good effort.